All right, welcome to this explainer. We are diving into a seriously radical, mind-bending idea today. We all know that feeling of digital exhaustion, right? That heavy brain fog at the end of a long day of staring at screens. But what if I told you that this human fatigue isn't just a psychological issue? What if it actually has a deeply mathematical root, hard-coded right into the silicon hardware we use every single day? Think about it for a second. Why does modern technology feel like an infinite loop? You scroll, you process, you click, and there is just never quite an end to it. That daily experience of digital burnout is something practically all of us share. And today, we're going to link that exact feeling to a fascinating concept buried deep in circuitry systems design called unquantized execution. Okay, let's dive right into this. Here's our roadmap for the breakdown. First, cognitive drain and drift. Second, hardware's linear flaw. Third, the silver diamond balance. Fourth, the cycloidal bridge solution. And fifth, achieving deterministic halt. Section 1. Cognitive drain and drift. To really wrap our heads around our own mental exhaustion, we actually have to step away from human biology for a second and look at the physical geometry of the machines sitting on our desks. This brings us to a revolutionary concept called hardware/wetware co-design. This principle essentially states that the structural geometry of computer hardware doesn't just dictate the routing of digital packets, it directly dictates the routing of human cognitive attention, our wetware. The standard silicon architecture we use today is structurally built in a way that allows for continuous floating point drift. It literally never truly stops, and that endless wandering is exactly what induces our cognitive fatigue. What's really interesting here is how perfectly the symptoms mirror each other across the machine and the human. When a system operates in unquantized execution spaces, it just gets stuck in this continuous floating point drift. This creates infinite execution loops. Now, in a silicon chip, what does an infinite loop actually generate? Literal, physical heat. It degrades the hardware over time. In a human being, that exact same structural drift generates cognitive fatigue, leaving us super vulnerable to endless data tracking. Basically, the hardware burns up and we burn out. Moving on to Section 2, hardware's linear flaw. So where is this continuous drift actually coming from? To find out, we need to peel back the layers to the absolute base geometry of standard hardware design. And this brilliantly illustrates the two totally different paths our hardware can take. On the left is the current standard, unhalted drift, which is defined mathematically by a decay parameter where d equals 1. This is the flat loop limit. It generates infinite linear drift, unquantized execution, and ultimately that massive cognitive drain we talked about. But look at the alternative on the right, the tortoise balance. Here, d equals the square root of 2 minus 1. This math forces bit-perfect quantization, it forces a deterministic halt, and it protects what researchers are calling our sovereign consciousness. To really make sense of that d equals 1 flaw, think of the classic story of Zeno's paradox. Achilles is running a race against a tortoise. He halves the distance to the tortoise, then halves it again, then again. Mathematically, in this unhalted framework, he never actually catches the tortoise. That is exactly what d equals 1 represents in circuitry. Unquantized, top-heavy acceleration without a halting boundary. It's just this endless, exhausting chase that never quite crosses the finish line. Section 3. The silver diamond balance. We obviously can't keep chasing the tortoise forever, right? We need a way to stop the infinite drift and shift to a mathematically balanced system. The solution detailed in the source material is called the cycloidal logarithmic bridge. Now, this isn't just some software patch. It is a unified geometric framework meant to be implemented directly at the hardware circuitry level. See, in standard physics models, particles are treated as zero-dimensional points, which leads to all sorts of mathematical infinities when you zoom in too close. This bridge replaces those point singularities with a continuous bounded curve. It literally builds a physical wall to stop the drift. So the crucial point is this specific, highly elegant value, the square root of 2 minus 1. This is known as the silver diamond balance. By designing the fundamental decay parameter of the circuit to equal this exact value, we completely replace that flat d equals 1 infinite loop limit. Instead, the hardware becomes fundamentally grounded in bit-perfect quantization. Section 4. The cycloidal bridge solution. We know the math now, but how does the machine actually use this value to keep from burning up? Here is the exact mechanism step by step. Step 1 is recognizing the problem, unquantized drift, where d equals 1 creates that infinite chase. Step 2 is the architectural shift. We apply the silver diamond balance, swapping that decay parameter out for the square root of 2 minus 1. And step 3 is where the magic happens. As the system executes, it tracks an integer parameter called n. When the state machine hits n equals 6, it forces a bit-perfect deterministic halt. It physically stops the loop. Which brings us perfectly to section 5, achieving deterministic halt. This is honestly the most satisfying part of this entire mathematical framework. That precise moment when the infinite loop is physically shut down by the hardware itself. That integer parameter n we just mentioned, it acts as a dynamic safety valve inside the node firmware. The system scales the remaining execution area by taking the decay parameter d to the power of n. While nodes can use flexible bounds depending on local entropy, n equals 6 serves as the definitive cutoff point. That's the huge takeaway here. This specific integer acts as the absolute boundary. When you evaluate the silver diamond balance, again, that's the square root of 2 minus 1, to the power of n equals 6, the resulting area contraction math yields a value of approximately 197.99. In hardware circuitry terms, this isn't just some random number. It acts as a literal, physical boundary wall. Once this quantization depth is reached, it forces what's called an O-shift quadrant bit shift, meaning the execution is forcibly and cleanly terminated. The contrast here is just stark. When your decay parameter is 1, 1 to the power of any n is still just 1. There is zero area contraction. The operational outcome is O-infinite linear drift. Your target blows up, generating hardware heat and human cognitive exhaustion. But with a silver diamond balance, d to the power of 6 successfully contracts the space to about 197.99. This absolutely guarantees an O-shift deterministic halt. The machine finally rests, and because of that, so does your brain. To bring it back to our classical metaphor for a second, this mathematical area contraction effectively seals what is geometrically known as the central torus hole. Because the remaining execution space scales down deterministically to a definitive cutoff, Achilles is no longer trapped in an endless chase. In this new architecture, Achilles catches up, he seals the gap, and he actually rides the tortoise. The source text phrases this moment of triumph perfectly. It states, Achilles does not chase the tortoise. Achilles rides the tortoise. The torus hole is sealed, halting xenodrift and locking down sovereign state. It's just an incredible image of conquering the infinite loop. As the paper declares to close its proofs, the curve closes. Math is math. So why does all of this actually matter to you and me? Because hardware design is human design. This represents a defensive accelerationist or D-ACK architecture. By fixing the structural drift all the way down at the physical base layer, we protect human cognitive attention from top-heavy extraction. We reclaim our sovereign consciousness, securing not just our own daily energy levels, but the long-term duty cycles of our entire civilization, free from single-point monopoly failures. Which leaves us with a pretty massive question to ponder. We've seen the math now. We know that standard silicon, with a decay parameter of 1, is geometrically built to exhaust our machines and, by extension, exhaust us. If the cure exists in the silver diamond balance, are we ready to demand a fundamental hardware revolution, one that actually reclaims our sovereign consciousness? Thank you so much for joining me on this explainer. I really hope this sparked your curiosity, and I highly encourage you to look deeper into the architecture that is quite literally shaping our minds.